Good evening, everyone. I'm Peng, speaking on behalf of Nuclei System Technology. It's a pleasure to be here today at RISC-V Summit, and I'm excited to introduce the Nuclei UX1030H RISC-V CPU IP. It's our next generation high performance course built for the RVA23 era. So Nuclei is a Shanghai-based RISC-V pioneer, founded in 2018. Our focus is on RISC-V CPU IP, subsystem IPs, and SoC solutions. So we have a broad portfolio spanning from 32-bit microcontrollers to 64-bit high-performance cores. And our IP has been deployed across markets, including AI, automotive, 5G, networking, and IoT. And the features rich configurations, functional safety, and information security. And today, Nuclei serves over 300 customers worldwide, and shipments exceeding 100 million units. RISC-V's open, modular, and extensible ISA has catalyzed explosive global adoption. According to SHD group forecasts, RISC-V SoC shipments is expected to reach 30 billion units by 2031, and rapidly expanding to industry-grade applications from low power to high-performance AI and computer engines. Riding with this momentum, Nuclei has become one of the China's leading RISC-V IP providers, with a rapidly growing domestic and international customer base. Okay, let me talk a little bit more about our portfolio. For CPU IP, on the top left, horizontally, we have product lines covering general purpose computing with the N, U, NX, and UX class, security by the NS class, safety critical applications by the NA class, and the intelligent compute intensive domains by the NI class. And vertically, we offer multiple architecture series from single issue 2-stage 100 series to multi-issue out of order 1000 series, meeting a wide range of performance, power, and area needs. On the left bottom, you can see we also offers SoC IP components such as bus fabrics, neural processing units for embedded AI, cryptographic accelerators, and various peripheral IPs. Our business is steadily transitioning from license-driven to loyalty-driven, reflecting our customers' long-term commitment and design success. To support RISC-V's growth in high-end systems, the community ratified RVA23 Profile last year. Its standard feature sets for 64-bit general-purpose cores. The RVA23 mandates extensions like hypervisors and vector, ensuring processors can support modern operation systems and virtualization stacks. It effectively provides a unified baseline for software portability and standardization, and serves as the official architecture profile for Android on RISC-V. So this milestone has prompted major companies worldwide to align their next generation OS and middleware stacks with RVA23. To meet this new standard, Nuclei launched the UX1030H this June. It's one of the first RISC-V IP cores fully comply with the RVA23 and available for licensing today. The UX1030 targets the ARM Cortex-A72 performance class markets, enabling standard Android and Linux environments on RISC-V. It's built on Nuclei's proven UX1000 microarchitecture. It addresses both the general purpose computing and AI compute-intensive workloads. So the key architectural highlights include scalable multi-core design. It supports a symmetric multi-core cluster, up to 16 cores per cluster, with coherent multi-level caches and the AXI ACE interface for SoC integration. As for the out-of-order execution, it has a 12-stage superscalar pipeline with 3 wide decode and up to 8 integer plus 2 vector issue per cycle, delivering a strong single-thread performance. As for the vector extension, it supports the RVV 1.0 with 128 or 256 VLANs options. But for the memory subsystem, it has L1 instruction and data caches, optional on-chip local memories for both instruction and data, and a shared L2 cluster cache. If you use the Nuclei bus fabric, it can also have optional NAS-level system cache. All the data cache are coherent and ECC protected for reliability. It also supports SV48 virtual addressing and hypervisor mode. So on the SoC level, we also provide IOMMU. It's used for secure resource isolation and memory virtualization, essential for trusted and virtualized systems. We also support the advanced interrupt architecture. It delivers high-performance, scalable, virtualization-ready interrupt handling. Our product also supports coexist of the legacy PIC with the advanced PIC configurations. Okay, so the UX1030 is based, as I said, based in Nuclei's self-developed UX1000 series microarchitecture. It has a 12-stage out-of-order pipeline. So on the front end, it has a 4-wide instruction fetch, a 3-wide instruction decode and dispatch. On the back end, the out-of-order engine has a unified scalar physical register file. In a typical configuration, it can issue 6 scalar instructions, including 2 load stores and 2 vector instructions per cycle. We have seen these features for the UX1030 before, except for the ISA extensions mandated by RVA23. Most of the hardware features are configurable. For example, you can configure the VPU VLANs, the size of each cache, the optional local memories, the optional local memory slave ports, memory bus protocols, and extra. So the UX1030 VPU complies with the RVV 1.0, and it's equipped with 32 vector registers. The vector register supports combined operation, UOMMU, enabling vector computation of up to VLANs times 8 bits. It supports data types including 8, 16, 32-bit integer, BFP16, FP16, and FP32. It supports a VLANs of 128 and 256 bits. So this VPU is optimized for day-level parallelism computing tasks, and it also employs many instruction-level parallelism techniques. So as you can see in the VPU, it has 3 vector pipelines, including 1 vector load stores, 1 vector type A instruction execution pipeline, 1 type B instruction execution pipeline. So each cycle, up to 2 vector instructions can be dispatched into the VPU. So 1 instruction per vector pipeline. And then up to 3 instructions can be issued for execution also one from each pipeline. So the vector pipeline also supports out-of-order execution as the scalar pipeline. Also, the scalar and the vector units shares memory resources. For example, the IOMMU, the cache, the date local memories, and external memories. This enables easy scalar and vector data sharing and management. Okay, so the UX1030 supports coexist of real-time and Linux Android application modes. We call it the dual mode. In practice, one set of cores in the cluster can run a low latency rattles, while others handles high-level OS tasks, enabling mixed criticality workloads within a single cluster. So in this example, the core 6 to 7 are running real-time processing modes, utilizing hardware features such as features for deterministic low latency memory access, such as the data instruction and data local memories, the physical memory protections, cache line locking, and you also use fast interrupt handling and rich fast interrupt features provided by the enhanced click. While core 0 to core 5 are running in the OS application mode, utilizing hardware features such as cache, MMU, PIC, and etc. So the cluster L2 cache is usually reasonably big, from 256K bytes to 1 megabytes. To support a dual mode operation, our cluster cache can be partitioned by software to feed those use cases. So in this example, the cluster cache weight 0 to weight 7 is programmed to be a cluster local memory. It serves as a shared memory space for all cores, avoiding external memory access and provide deterministic memory access in time. Weight 8 to weight 11 are programmed to be a cache for the OS application cores, and the weight 12 to weight 15 are programmed to be the cache for the real-time application cores. So this static partition of cache ensures the cache capacity reserved for the real-time operation cores and reduce interference from the application mode cores. So the UX1030 has a configurable I/O coherence ports to support data coherence and sharing between multiple external masters with the processor. It supports external masters such as NPUs, accelerators, PCIe controllers, DMAs, and etc. to access the processor L1 cache, the cache, and the cluster L2 cache, and also the cluster local memory. It maintains cache coherence without any software intervention. It also helps to reduce I/O access latency and enhance overall bandwidth and performance within a heterogeneous system. So the UX1030 is currently in partner design phase, with the backend place and route results showing around 1.6 gigahertz on TSMC 22 nanometer process technology. The picture on the left is showing a layout for a single core, and the picture on the right is showing a 4-core cluster. So the timing closure and the reference designs makes the UX1030 ready to deploy solutions for your next generation RISC-V SoCs. So as for performance benchmarks, the UX1030 achieves 5.35 dMIPS per megahertz on dry storm, and our test strictly compliant with the ground rules without using any inline options. And it can achieve 8.5 core marks per megahertz it's a leading result for the standard-only core RISC-V cores without using any proprietary instruction extensions. As for the VPU, we have also tested have multiple benchmarks. For example, the matrix multiplication, it can have a speed up between 5 times to 17 times. And you can see other results for 1D convolution and FIR and other math libraries. As for crypto, we also tested multiple algorithms on FPGA. The speed up is between 5 times to like 17 times. This is a demo for hypervisors. So as you can see on the left, there are 3 terminals running connected to the VM running different tasks. So VM1 and 2 are running different Spec06 benchmarks, and VM3 is running some network tasks. On the right, you can see the host Linux, and it shows 3 guests launched from it. Yeah. So the launch of the UX1030 strengthens Nuclei's position in the high-end RISC-V CPU IP markets, enforce the domestic IP supply, and accelerate the software ecosystem's migration towards general-purpose computing platforms. Moving forward, Nuclei will continue to advance RISC-V IP in general-purpose processing, intelligent computing, information security, functional safety, and virtualization, building a comprehensive, deeply integrated RISC-V ecosystem and driving sustained performance growth across platforms. So in summary, the UX1030 fills the Cortex-A72 class performance niche within the RISC-V landscape, fully compliant with RVA23, ready for production, and available today. Thank you. I'm open to your questions.
You explained about the cache partitioning to prevent the in case of dual mode, but how about the interrupt controller AFLIC in case of dual mode to prevent the interference to setting the interrupt between 2 OSs? I think it has to be prevented.
Yeah. So on the SoC level, we provide the interrupt distribution unit, and it can allow you to route different interrupts to different cores. So it helps you to do a like static partition.
So pardon?
So it doesn't have any interference.
What mechanism are you using to partition or prevent the AFLIC interference between 2 OSs?
Sorry, could you say that again?
In case of dual mode, there are Linux and RTOS, but AFLIC is a shared resource.
Oh,
the setting must be prevented to each interrupt routing path, like the cache partition. Yeah.
Yeah, that is done through interrupt distribution unit we provide, so it can help you to route the interrupts to the reduced cores and other interrupts to the Ratos cores. So I did not expect to have one interrupt shared by both applications, right?